Hi class, this is your teacher, Bridget Schwans. I hope you all are doing well. So this is the solution to the let's play a game discussion problem. And I hope you find that really intriguing. So the problem goes, and there was 3 doors and there's a car behind one of them, and you want to choose the door that has a car. So it starts out where let's say I pick door number 1, and I think door number 1 is where the car is. The probability of the car being behind door number 1, because there's one car and there's 3 doors that it could be possibly behind, so there's one outcome I want, right? And there's 3 possible outcomes that I could choose from. The probability of that car being behind door number 1 is 1 out of 3, right? Because it could have been here or here. It could have been any 3 of those spots, and so it's a 1/3 chance it's behind that door. Now, if we think of the complement, and the complement says, if you add, basically it's just saying, if you add up all of the different possibilities in that sample space, then that needs to be 100%. So like if I took, the probability of it, the car being behind door 2, and the probability of it being behind door 3, and if we add up all of those probabilities, the probability of it being behind door 1 plus the probability of it being behind door 2, that's what I'm meaning by P of 1 here. I just mean, well, let's just call it A. Well, that's okay. We'll say P, when I'm saying P of 1, it really means like a situation. When you plug something into a probability, when they write this notation P of a number, we're not plugging in 1 to anything. I'm just using the 1 is the situation in which the probability of the car being behind door number 1, okay? And so it's a scenario. The 1 is a scenario. It's not a number that you plug in anywhere, okay? And then plus the probability of it being behind door 3, the probability of them being behind all of those is 100%, right? Or 1 whole if we want to write it as decimal form, right? We are sure the car is behind one of those doors. If I add a probability of the first door plus the probability of the second door plus the probability of the third door, 1/3 plus 1/3 plus 1/3, 1 whole, or if I write it as a percent, 100%, right? So that means that if I take the probability of it being behind door 1 plus the probability of it being behind either door 2 or 3, that it would still have to be 1 whole. And so they call these, whenever you can take all the possible outcomes and break them into 2 equal groups, and you call one group the event, and the other group is the complement of the event. And so that's what's happening. We can do here, like it's you have the outcome of door number 1, but then you have the outcomes of door 2 or 3, right? So the car is going to be either behind door 1 or it's behind door 2 or 3, one or the other, but those make up all the possible outcomes of this probability event. So the probability of event 1 of it being behind door 1 plus the probability of it being door 2 or 3 has to add to 1 whole, which we could rewrite this equation and we could say, okay, subtract 1, subtract the probability of 2 or 3 from both sides, or subtract the probability of 1 on both sides. And we get the probability of the car being behind door 2 or 3, right, is 2/3. Because the probability of 1 was 1/3. Should back up a little bit. That's 1 minus the probability of 1. Well, probability of it being behind the first door was 1/3. So the probability of it being behind the door 2 or 3 is 2/3. Hope you guys are going with me. I know I'm talking a lot, but so basically what I'm saying is the probability of it being behind door 2 or 3 is 2/3, right? Wouldn't it be nice if you could just like pick 2 doors instead of 1 door, and if you get behind the 2 doors, then you win. If it's one of the 2 doors you chose, then you win the car. But that would be better, right? So, anyways, so we have the probability of it being behind door 1 was 1/3. The probability of it being behind one of the other doors there is 2/3. But when they open that door and reveal it's not behind door 2, now all of a sudden, the probability of it being behind door 3 is 2/3. So I'm telling you that you have a twice as much, if you switch and you take door 3, you are twice as much likely to win the car as if you would have stayed with door 1, the one you chose. Isn't that crazy? That's just crazy. And you can see it that, and again, because the probability of door 2 or door 3, of the car being behind door 2 or 3 it adds to 2/3. And as soon as you say, hey, probability of door 2 is 0, of the car being behind door 2 is 0, then the probability of door 3 ends up being 2/3. And so because the probability of 2 or 3 is going to equal the probability of 2 plus the probability of 3. And you can't, the car can't be both behind 2 and 3 at the same time. So we don't have to worry about that. So we can just use this simpler equation of the OR equation. But the probability of 2 is now 0. We know the probability of 2 or 3 is 2/3. So that leaves us to believe the probability of 3 is 2/3. And I can also further show it to you by just setting up this example and actually doing the experiment and hiding a car behind a door and then pretending there's a car there and then opening them up, and then you'll see that you actually win the car twice as much times as you do if you would have just kept your original door when you play this game. I know it's really backward thinking, and I feel like it's such a weird, you're like, why, but why, right? But here's something to kind of help you think about it in a different way. Let's say that there's a bunch of soldiers that go off to war, right? And let's say there's 100 of them. Well, that's a lot. Right? And let's say that before all these soldiers went off to war, you chose one of them and you said, hey, I want you to defend me. If the war comes to our town, and I need to be defended, I want you to defend me, right? Okay, let's say you choose this person, right? And let's say all of these other fellows go off to war, right? There they go. Well, let's say that 90 of them die in war, right? Okay, so dead, and we have 3 guys left, right? Now the question is, do you still want to go with, you chose this guy this guy, Joe, to defend you. Do you now want to keep Joe as your personal bodyguard? or would you like to switch and use one of these guys that is back from war? And in my thinking, I'm like, well, wait a second. Like this guy, let's call him Jose. If Jose, came back from war and he happened to be one of the 10 out of 100 that didn't die, like, there's something special about him. He could probably fight really well, and he survived the war, so he's probably a better, bodyguard than this guy who I don't know anything about, So that is the kind of mentality that's kind of going on here with this game. Let's do a deal. Like when they eliminate that door 2, it makes door 3 special, because hey, but you didn't choose. You kind of survived. You could have been disqualified, but you weren't. So you have like an extra. There's something special about you that you survived that. And the same thing about like the guys at the war. Like, hey, you survived and the others didn't. So there's something special that would make me want you over the other. So that's kind of why. So it's just to kind of help you kind of think about it. All right. Well, I hope you guys all found this a really fun and entertaining question. And yeah, email me if you have questions. Bye.